Hey, welcome to Quick Concepts. Today we're going to be talking about parallel lines cut by a transversal. This is part of our geometry quick concepts. You're going to see this throughout Algebra 2 and into advanced math for the Saxon curriculum. So first of all, what defines a parallel line in the problems? So you'll see things that look like this, and they'll have these little arrows. So that denotes parallel lines. So that'll be the first thing you notice in the problem is that there's parallel lines. Okay, so then what's a transversal? So again, you'll see something like this. This is our transversal. And it's just fancy for it transverses, or I guess traverses. I'm not good with words. Anyway, so this is just to kind of help you understand these problems in general. So a couple things you need to know. First of all, a flat line equals 180 degrees. Okay, so what I mean by a flat line is if I were to ask you what is this angle right here, notice it's a flat line, it's 180 degrees. That's going to help us decide, like if this was given as 4 degrees and they were asking what is x, we could easily say 180 minus 54 is x, 180 minus 54 is 126. So that's why that piece of knowledge is important, okay? Another thing you need to know about parallel lines cut by transversals is how the angles correspond to each other. So what do I mean by that? So let's say you have something that looks like this, okay? So there is a geometric postulate that says parallel lines cut by a transversal means two things. Number one, corresponding angles are equal. Sorry about that. I hit that button on the pen. It just disappears. So what does that mean? Well, let me show you in red. This angle corresponds to this angle, so therefore they are equal. You can say this angle corresponds to this angle, so therefore they are equal. The other thing it tells us is that alternating interior angles are equal. So what do we mean by that? Well, let me use these. So for instance, if you have something like, so let's say this alternates with that, so those are equal. Another rule that governs that is something called vertical angles are equal. And these are just angles that share a vertice. So another example would be like if I had something like this, these are vertical angles and they're equal. So parallel lines cut by a transversal means corresponding angles are equal, alternating interior angles are equal. You need to keep in mind that a flat line equals 180 degrees. And if you have all that, you're not going to have any problems doing the angle problems. So let's do a couple examples to see if you can understand what I'm talking about. Okay, so the first thing on this one, this is your first example problem, is I'm going to start with my numbers. And I'm going to notice that this right here makes a flat angle. And we remember that a flat line or a flat angle equals 180 degrees. So if I were to say, well, if I were to add 70 plus 2c, it would equal 180 degrees. At this point, you're just dealing with algebra. Geometry's over, back to algebra. Okay, so in this case, we only used one piece of information. We used the fact that a flat line equals 180 degrees. But in order to figure out what A and B is, we have to use these. So first of all, I'll start with the corresponding angles being equal. So 2C corresponds with B. So I can write that down. I can say, well, 2C has got to be equal to B. Well, I figured out what C was, so I can say 2 times 55 is equal to B. So B is going to be equal to 110 degrees. And then at this point, I can use the fact that flat line equals 180 degrees to solve for A, or I can use my rule that says alternating interior angles are equal. So this and this are equal. So I can say A is equal to 70 degrees. And again, like I said, if you forget that one and you don't have time to come back to this and you're on a test, you can always say, well, I know that B plus A makes a flat angle. So this is 110. So A must be 7. So either way is fine with me, but this is just an example of how you can use these. So let's try a couple more. Let's do this one, but these aren't necessarily parallel lines, but they're dealing with angles. And so therefore, I've already gone over all the rules. So first of all, whenever you see this square like this, understand that this stands for 90 degrees or a right angle. Okay, so if this from here to here is P, this is X, this is 2Y, and this is 30. Okay, so the first thing I'm going to do is, again, I'm going to go where the numbers are, and the numbers are right here. So if I were to look at this, I can see that this is a flat angle. So I can say 30 plus 2y plus 90 equals 180. Now again, like I said, one step, I'm away from geometry back to algebra. I'm going to add 30 plus 90, which is 120. Then, of course, the number one thing in algebra is to get the variable alone so we can figure out what it equals. So I know that y here is equal to 30. Now, the next thing I'm going to use is I'm going to use our rule that vertical angles are equal. I'm going to show you that this angle here is equal to this angle here. So I can just say, well, x is equal to 30 degrees then, just like that. And then lastly, to find my p, I'm going to go ahead and use the flat line equals 180. So I can say, well, p is going to be equal to 180 minus x. We know what x is. So p is equal to 50. Okay, so that covers pretty much angles and things like that. Let me see what my time is right now. Okay, so we're just under 10 minutes. Let me just do one more just to kind of cement it home. Examples are the best thing you can do in C and math to help you figure out what you're dealing with. Okay, so again, that's got to be 180 degrees. I can subtract 60 from both sides and see that P is equal to 120. Vertical angles are here and here, so that tells me 10x is equal to 60. Dividing both sides by 10, x is equal to 6. And then vertical angles here and here. So I can say P is equal to 4y. Well, I know P is 120. And again, I can see that y is 30. Okay, so that is it for parallel lines cut by a transversal dealing with angles.